The size of offshore wind farms is growing, and they're being built further from shore. This requires longer cables that transmit more power. Cables are critical assets in high-risk environments, so a thorough understanding of conditions above and below the seabed is key. The first step involves a desktop study. Applying decades of experience with geodata, a ground model is created to assess risks for the suitability of routes early on. A cable route survey from the offshore wind farm to the onshore landfall identifies detailed soil conditions, environmental constraints and hazards like thermal risks. Airborne LiDAR, environmental, geophysical and geotechnical data is acquired to refine the ground model. This provides input for cable and route engineering, so you can choose the optimal route, where both cost and risks are minimized. Seabed mobility is assessed to determine the impact on cable burial and scour, to improve the reliability of the cable and reduce the need for repairs over its lifetime. To support installation of your cable, we advise on the best tool and burial depth for efficient operations. Our geodata insights improve the design and reliability of your cables to power renewable energy for a safe and livable world.